We have already seen UPGMA, which is basically a distance-based matrix to generate a phylogenetic tree. जो UPGMA था, that resulted in a rooted tree, where root was the parent of all other nodes. Similarly, we have a neighbor join method, which will work on a distance-based matrix, but it will result in unrooted tree. जो हमारा tree बनेगा, वो unrooted होगा. अब इसका क्या idea है? Basically, जो हमारा neighbor join method है, it is based on the assumption of additive distance matrix. Additive distance matrix क्या होती है, ये हम देखेंगे. Similarly, I will give a practical example of neighbor join method. Basically, our goal in neighbor join method is to find a tree that minimize the scale of errors and give us a best suited or optimal tree. What is additive condition? So for additive condition, we will have to look something into mathematics. So basically that is, if we have a matrix M with distances L into L, so rows and columns which are L, then what is additive condition? We have distance between II between two sets is equal to 0. Similarly, whenever we have Dij, that should be greater than 0 if I and j are not equivalent. And similarly, we have Dij is equal to Dji. So for all ijk, it should be equal to Dik is less than or equal to remaining two parts, which are ij and jk. That is also shown in the figure also. So we have three vertices ijk, and then we have Dij, it should be less than or equal to other two parts. So again, what will happen with the additive condition? So if we have distance matrix M and it has L objects, then it is additive if there is a tree T such that L of its nodes correspond to L objects with positive weights on the edges, such that for all I, j and distance between ij is equal to dtij, the length of the path from I to j in the T matrix. Okay, so here I have given an example of additive matrix. What is it? Basically, I have three things I, j and k which are at the terminals, and then what happens if I want to calculate information or distance between ij, I have to calculate two segments which are a and b. For ik we have to calculate a plus c, for jk we have to calculate b plus c. And finally, distance between k and m, which is our two internal nodes, what would be? It would be half of the distance between ik and gk and minus ij, and it would be greater than or equal to 0. So for additive information, what is our conclusion? We are getting information of internal nodes which are based on the terminal nodes, and then we are getting half of that information, which consists of plus summing of first two distances and then removing the third distance. So what is an additive tree? There should be for 4-point condition, what would be the condition for 4 points? So condition is again similar to the 3 points, that it would be any 2 points such as dik plus djl, it should be equal to dil plus dkj, which are shown here, and it should be greater than dij plus dkl. So it is extension of 3-point neighbor or additive tree. So the theorem is that there is much mathematical details which are provided here. I will explain this information with the help of a practical example, and then this information is available in your handouts, and you can also see course books for this information. So I will directly go to this practical information. So what is that? So again, if I have a matrix which is shown here by 4 columns which are ABCD and 4 rows which are ABCD. And now what I want to do is I want to make a tree which is unrooted tree. So first step would be selection of A and B, and then I will calculate these distances between each individual element, which is DAB, DAC, DAD and so on. So it would be roughly 6 different distances which are given with their values in this diagram. If I move on, so at the first step, what would be the first step would be that we have another node which is shown as E, and E has A downwards and B A as upwards and B as downwards, and with their weights 1 and 2, which is calculated in the following slide. Similarly, if I continue this thing for ECD, so instead of A, I am placing AB with E, and then I will compare its distance against other two columns which are C and D. So what will happen? this complete calculation will give us a diagram which would be something like this, that this this matrix will be replaced by will have another addition which is F. So F will be in middle and C and D will be its in upper and lower direction with their following weights. So finally what I will do, I will combine this tree with the previous tree, and this will be something like this. So 4 will be the total weight which is inside between E and F. So we have added two more nodes which are E and F, and they are combining the remaining nodes which were present in the previous trees. So what are comments basically? So what will happen if we have a distance matrix and we will use a neighbor joining method, we will construct an unrooted tree which will be unique for that case. Even what we can do, we can use non-additive matrices, but the problem would be then we don't have a common unique tree if we are using non-additive matrices. So conclusion is, by using neighbor join method, we can construct unrooted trees, and that if we use additive matrix, then it will be a unique tree.